In this video, I'm going to show you the piece of a quadratic formula that is called the discriminant. I'm going to talk to you about just that small part of your quadratic formula and what it can tell you about the picture of your quadratic. And so I want to first just talk about the two ways that we've already learned how to solve a quadratic equation. So that means if you had something like this, ax squared plus bx plus c. And the most important part is that you have the square term. You may or may not have a linear term. You may or may not have a constant term. But we've started to learn two other ways. One of the ways is called factoring, and another way is called the square root method. But in this video, we are not going to do the two ways that we've already learned. We're going to use a method called the quadratic formula. And this formula can be used all the time. So if factoring, if you couldn't figure it out, if square root method didn't figure it out, then you would use quadratic. But technically, you could always use quadratic formula. And so I'll talk to you about just kind of the key components. First, the discriminant part of your quadratic. And I'm going to highlight, here's the actual formula here. I'll box it up for you. This is the formula. But the piece of the formula, just a small part of it, that is called the discriminant, that is the part that is underneath your radical sign. And the discriminant can have 2, 1, or no real solutions because of it being, and I'll talk to you about this down below, being positive, 0, or negative. And so this discriminant can tell you something about your picture and also your solutions before you even do the whole formula. And so quadratic equations, because you have a square, can have up to 2 solutions. So you could have 2 solutions, 1 solution, or none actually. And this would be x-intercepts specifically. And here's just kind of a rough picture. It'd be a parabola, so a U-shaped graph, and what we're going to look for is how many times your picture, based on the discriminant, will touch the x-axis, and we'll get into that in just a second. But before you solve a quadratic equation, you can determine how many real number solutions it has by just that discriminant piece alone. And the discriminant piece in your formula is what's underneath of this radical. See how we have our A, B, and C parts of our formula? It would be our b squared specifically, so this number, the coefficient in front of your x squared, and then you subtract 4 times the a coefficient in front of your square term, and then your constant multiplied together. And so make sure you use parentheses when you square. That would be something that I would note. And then 4 times a times c, make sure that is in parentheses. So if one of these is a negative, subtracting a negative, you're going to end up getting a positive here. Subtracting a negative turns to a plus. So these 3 things here, number 1, the discriminant tells you the number of solutions a quadratic equation can have. It can also tell you if the quadratic expression can be factored, and we'll get into how we know that. And then also you could sketch a graph based on your discriminant. So here are the 3 discriminant types. And here they are. I'm going to highlight these over here. So you could have a positive discriminant, meaning this will simplify to be a number greater than 0. That means you would have 2 solutions. And your picture would look something like this. Your quadratic will cross through the x-axis in 2 places, which is why we say 2 solutions. Now, if you had a discriminant, this b squared minus 4ac, if that turned out to be the number 0, then you would have 1 solution. And I want to show you how the picture will alter here. You'd have 1 intercept, and then your graph will go either up or down, really, because it could open downwards too. And then the last option would be if this discriminant, the b squared minus 4ac, is a negative, then you will have no x-intercepts, meaning no real solutions. So think of a parabola that opens up above your x-axis, and so it never actually touches. And so that would have no x-intercepts, meaning no real solutions. And then over here, can you solve the quadratic equation? Could you have done factoring? This is how you would know. If your b squared minus 4ac is a perfect square, then you could have factored. And if it was not a perfect square, then you probably should have used the quadratic in the first place. Okay, now the very last thing on this page before we start doing some examples here is the discriminant. In order for an expression to factor the discriminant, your b squared minus 4ac must result in a perfect square. So what we're going to do is show you an example here. Our a, the number in front of our x squared, is a 1. B is the coefficient in front of the x, including the sign, so -8. And the c, the number term without a letter, your constant, is -11. And now if we actually do the discriminant formula with our a, b's, and c's, b would be -8 in parentheses squared, and then minus 4 times 1 times -11. So this is going to be 64, because a negative times a negative makes a positive. And then subtract 4 times 1 times -11 is -44. And when you subtract a negative, you would get 64 plus 104, which would be 108. So state my number of solutions. My number of solutions would be 2 solutions because it's positive. But 108 is not a perfect square, and so I would not use factoring. So since it is not a perfect square, we can solve by another method, and I'm going to show you on the next video some examples of actually now finding the discriminant, and then in the videos after that, we're going to start doing the entire quadratic formula. So stay tuned.